Heat transfer. So when we heat something up, what we're doing is we're transferring energy from the heat source to the material that we're heating. It is just what we've been talking about all the way through this topic. It's heat being transferred from one place into another. The heat isn't being created, it's just being transferred. So we've got two key terms, thermal conductors and thermal insulators. So thermal conductors are materials that allow the thermal energy to move through them really easily. So metals are really good thermal conductors. Thermal insulators are materials that don't allow the thermal energy to move through them. So that's things like fiberglass and wool. They're really good thermal insulators. Your duvet, it's a really good thermal insulator because they trap air. Now this is a topic that we actually know a lot about without realising how much we know. So if we're cooking something, I've got a little frying pan here. If we're cooking something, we would generally use a wooden or a plastic utensil rather than a metal one. But why? Well, because metal is a really good thermal conductor. So if I was cooking using this, despite the fact that I'm heating up the spoon end because it's in the pan, this end would also get really hot because it's a metal. It's a really good thermal conductor, and I'd burn my fingers and then I'd complain. So instead, we would use a material that's a really good thermal insulator or a less good thermal conductor, because then we're not going to burn our fingers. Here I have a cup of coffee. Now I want us to imagine that I'm going out to a rugby game. I'm going to stand and watch, and I want my coffee to stay hot. What can I do about it? Well, I could wrap it in a material. So I've used a plastic bag here. A plastic bag is not the best thermal insulator because it doesn't trap as much air. So a better thermal insulator would be some towel. It traps air, and so it keeps the thermal energy on the inside and stops it being transferred to the surroundings. Now, how could I make this even better? I could add more layers of insulation. So there are two things I can do to keep something warm, to reduce that transfer of thermal energy. I can use a material with a low thermal conductivity, because the higher the thermal conductivity of a material, the higher the rate of energy transfer through it. So if I don't want the energy to be transferred through it, I need to use a material with a low thermal conductivity. And I can make sure that that material is as thick as possible. And that's what we do. We do it all the time, don't we? We put insulation inside the layers of our walls and the roofs of our houses to try to keep as much thermal radiation in on the inside, to reduce that thermal conductivity. And you probably know that if it's snowed and you look at the roofs of the houses around you, those with snow still on the roof, they're doing a better job of stopping the transfer of thermal energy from inside the house to outside the house, so it's not melting the snow. Make the layers as thick as possible. We do this as well, don't we? When we get dressed for the winter, we put more layers on because we want to reduce the transfer of thermal energy from inside us to the surroundings. And that's everything on this little section.